Okay, so it's 3 o'clock. Let's start today's class. I welcome you all to this NPTEL TA session of finite element method for the January to April 2025 batch. So this is the week number 6 we have done. So this is the TA session for week number 6. Uh, my name is Nikhil Gupta and I am the research scholar in Department of Civil Engineering in ISC Bangalore. So this class was going to happen yesterday, but due to some unavoidable circumstances, I have to shift to today, that is Sunday, 2nd March. So, what is the agenda of today's class? It's that I'll start with the solutions of the assignment 5, which is already submitted by you all, and then I'll cover the questions which are related to week number 6, and that will be helpful for you all to solve the assignment number 6. Also, for this time, they have given some of the codes also. So these codes will be helpful for you to solve in the problems of the assignment number 6. So I'll discuss that as well. That will be very helpful for you all to understand that code and solve the problems. So let's start today's class. So this was the first question of the assignment, where it says, what kind of polynomial is used for interpolation of rotation and displacement in FEM of Timoshenko beam element? So you all know, when you have a beam element, you give this as 1, you give this as 2, you give this as 3, you give this as 4. So for a member you have 4 element like this. For a Euler Bernoulli beam, you have in the theoretical class that it is a Hermite polynomial. What is this? This is the interpolation function. But in this question, it has been asked about the Timoshenko beam element. So the difference between the Euler-Bernoulli and the Timoshenko beam is that we have to consider the shear forces as well, the effect of shear as well in the beam. So for that, we know when we write the interpolation function, in case of Timoshenko beam, it will be Lagrangian. This is all covered in the class. So the answer for this question is B. Oh, sorry. The answer for this question is A, which is Lagrangian. So the second question, it says, the Timoshenko beam theory, primary variable are W and theta. If we use linear interpolation for both variables, what will happen for thin beams? So let's figure out the options which are given. Contribution from shear energy will be negligible and bending locking will happen. This is wrong. Bending and shear, both energies will become 0 and shear bending locking will happen. No, this is also wrong. So when we see the third option, which says contribution from bending energy will become 0 and shear locking will happen, we have understood in the class notes that this is correct. So this is the third question. Apart from theory, let's solve this question. It says a cantilever column is subjected to axial load P naught only. If its total potential energy is written like this, Okay. So by looking into it, we can directly say, since KSGA terms are coming, that is a Timoshenko beam. So they have defined W as the transfer deflection, theta as the rotation, and they have asked what will be the corresponding governing equations of the beam. Consider W and theta as primary variable, and a different psi is also mentioned like this. So let's start solving this problem. This is the cantilever beam, and a loading P is given like this, which is P naught, so it will take as a P naught. Now let's start writing the potential energy function, which for the Timoshenko beam, which will be EI 0 to L d theta by dx whole square dx plus ksga divided by 2 from 0 to L. It will be dw by dx minus theta whole square dx minus, since point load is also there, so that will also contribute in the potential energy function. So what it will give, P naught by 2 0 to L, and dw by dx whole square dx. So this potential energy function we have already studied in our class, so directly I have written from there. Now what we can see, that this pi, which is a potential function, is a function of x, which is the dependent variable, then theta, then w, and two more terms which are theta dash and w dash. So we got our potential energy function. Now what we have to do, we have to do the variation, apply the variation principle. So what we'll do, we'll put the delta 1 of pi, and that will be del pi by del theta minus d by dx of del pi by del theta dash, which will be equals to 0. Now as you can see, there we have two variables theta and w, so two equations will be formed by the variation analysis, and the second equation will be same. This is based on theta, and this delta 1 pi will be based on w, so that will come as del pi by del w minus d by dx of del pi by del w dash, which should be equals to 0. Now let's solve this problem to get the differential equation. When you solve this, what you will get, del theta 1 pi equals to ksga by 2. Now what we are doing, we are differentiating the this equation in terms of theta. So theta term is only this, so that will be ksga by 2, and 2 will 2 cancel out, and dw by dx with minus 1. So what we can write here, we can write here ksga divided by 2 with dw by dx minus theta and into 2 and minus 1. So along with this, we have d theta by dx also. So what will we do, minus d by dx ei by 2 into 2 twice of theta dash equals to 0. So this is the equation 1, but let's solve this further. So what it will give, ks ga theta minus dw by dx minus d by dx of e I theta dash equals to 0. When you find the equation, it will be d by dx of e I d theta by dx plus ksga dw by dx minus theta equals to 0. So this is your equation number 1 obtained from one of the variational principle we have solved with the potential function. So let's solve this second equation now. So when you will solve this equation, what you will get? You will write delta of W, first principle of pi, equals to del pi by del W minus d by dx of del pi by del W dash, which equals to 0. So now again what we have to do? We have to use this pi functional and we have to differentiate on the basis of W. So when you do it, you will start, since there is no W term, that will be 0. Then d by dx of ks ga by 2 into 2 dw by dx minus theta minus p naught by 2 into 2 dw by dx equals to 0. So what I have done? I have differentiated this term on the basis of W. So there are two terms, this and this, where W is coming, so that will cover that. Now let's simplify this equation. So when we simplify it, what we'll get? We'll get d by dx of ks ga with dw by dx minus theta minus p naught d2w by dx square equals to 0. Now in our question, what it is given, that this assumption is there, so let's assume that xi equals to ksga dw by dx minus theta, which is already given in the question. So we'll write d by dx of xi minus p naught d2w by dx square equals to 0. Now let's focus on the solution. One more thing, the same assumption we can assume in the first equation as well. So that will give you d by dx of ei d theta by dx plus ks. Wait, this is full xi, so this will be xi equals to 0. So this is the equation number 1 we have got. This is equation number 2 we have got. Let's focus which answer it is. So if you see, the answer is C part. This is okay, correct. So let's focus on the question number 4. Let's read it. So what they are asking, identify the correct statement regarding the consistent interpolation in Timoshenko beam element. So you must have studied in the class about the consistent interpolation. Let's see what it is. So in consistent interpolation, we keep dw by dx and theta order same. So since we are keeping it same, so directly we can say that since this is dw by dx, this is theta, so displacement will have higher order of differential equation, higher order of polynomial. So if theta is of order n, then displacement will be of order n plus 1. So if you look into the options, the first one says displacement and rotation both are interpolated with same degree of polynomial. No, not same degree but same order. So other says displacement is interpolated with n plus 1 order polynomial and slope is interpolated with the polynomial order n. Yes, we have discussed this. The third option is saying slope is interpolated with n plus 1 order polynomial and displacement is interpolated with polynomial of order n. So this is also wrong. This is reverse. So the answer is B, where we say the displacement is of order n plus 1 while the slope is of order n. So the about the question number 5 asked in the assignment number 5, it says what is the order of highest degree of highest derivative present in the weak form of governing differential equation in Timoshenko beam theory. So this is our mathematical question. Let's start solving the question. So let's start by writing the governing equation of Timoshenko beam theory of the Timoshenko beam. So there are two equations related to it. The first one is d by dx of ei d theta by dx plus ks ga dw by dx minus theta equals to 0. And another one is d by dx of ks ga dw by dx minus theta plus q equals to 0. Can you tell me whether it is strong form or the weak form, the governing equation? I'll wait for 2 minutes so all of you to think. Since there is no weight function attached to it, so this is a strong form. So let's assume this as first A and this as first B. Since there are two equations of the governing equations, so what we have done, we have mentioned two equations as 1A and 1B. Now we have in question it is asked what is the derivative present in the weak form. So from this strong form we have to make the weak form of this governing differential equations. Let's make the weak form. Okay, so what we'll do, we can have a two weak form here as well, as we have two strong forms. So in the first one what we'll do, we'll multiply the first weight function as v1 multiplied with 1a, and we'll do a differentiation integration as 0, and other as v2 into 1b dx is equal to 0. So by solving these two equations, we'll get the two weak form equations of the problem. So let's start with the 1a. So we'll put 0 to L v1 d by dx ei d theta by dx plus ksga dw by dx minus theta dx is equal to 0. Now we have to solve the integration, so we'll use integration by parts. So it will be v1 ei. Now by that this time I know you are confident enough to apply the integration by parts, because it's the basic of FEM. You have all should have a good hand on it. So we can directly write it v1 ei d theta by dx from 0 to L, then minus d v1 by dx ei d theta by dx plus v1 ks, and it will be g a omega w from 0 to L. This is a boundary term, minus integration of 0 to L. Then which one is remaining? It's this one. The one more term is d by dx of v1 ks ga w dx, and minus 0 to L v1 ks ga with the theta 1 is dx equal to 0. So this is the this full is the weak form of the first equation. Similarly, similarly, we can find it with 1b as well. So when we solve 1b, so we'll get solve using 1b. Okay, so we can write 0 to L v2 d by dx ks ga dw by dx minus theta plus q dx equals to 0. Again we have to apply integration by parts. So what it will become? v2 ks ga dw by dx minus theta. Since it is a boundary term, it will be having a boundary condition of 0 to L, then minus 0 to L dv2 by dx ks ga. With this it will be multiplied dw by dx minus theta dx plus the q2 term, which will be 0 to L v2 q dx is equal to 0. So this is the another weak form equation we can get from the second, or we can say 1b equation of a strong form. So what question is asking? Question is saying what is the order of highest derivative present in weak form? So we have got the weak form. Let's see highest highest order degree. It's highest order. So what we can say? This is order 1. This is order 1. This is order 1. All are, this is order 1. So we say in equation 1a all are of order 1. Now let's check with equation 1v as well. So here it is 1, here it is 1, here it is 1. So highest order is 1. So in total means highest order of derivative present in weak form of Timoshenko beam is 1. Simply there is a option we can mark it as 1. So B is the correct answer. Now let me ask one more question. Let's make a spin off of it, this question, and let me ask, what if highest order in governing equation or governing equation or the strong form is asked? Will the answer will be changed? I'll give you 2 minutes to think of it. I'll open the strong form equations to have a look on it and think about whether the highest order derivative is same as 1 or not. These are two strong form equations we have written. Directly by looking, we can understand what is the highest order derivative in these two differential equations. In weak form, we have got the highest order as 1. What about this? Okay. So uh, what we can observe here, that we see that this is d by dx, this is d2 by dx, d theta by dx. So making this, it will make 2 here. This is only 1. Then d by dx is here, d by dx is here. It will become 2 here. So directly we can say that the answer is 2. So in strong form we have a highest order as 2. In weak form we have the highest order of 1. Let's go to the next question. Let's read what it is saying. Then I'll start reading. So it says, in reduced order integration, the submatrix K22 can be written as follows. We have to identify which is K22 is given like this. As I told you, by seeing it, we can tell it's the Timoshenko beam stiffness. Now, correctly identify correct statement corresponding to the numerical integration to evaluate this. Okay, so let's before going to the option list, let's write some theory. So this is 0 to L ei d phi I by dx d phi j by dx of dx. Now plus 0 to L ks ga phi I phi j into dx. Now as we all know, this term is same as Euler velocity. And this term is coming due to shear, which is the main difference between the Timoshenko beam theory and the Euler beam theory. So in theory, you must have remember that it has been discussed that for this integration we use full integration, and for this we use reduced integration. So if you look into the options, what it says, the first term is integrated with reduced order and second term is integrated with full order. So no, it is wrong, because we have understood that first term is integrated with full integration while the second term is integrated with reduced integration. So it is opposite of it. So third second one says the both of them are evaluated with the full order. So no, we have seen it. Both of them are evaluated with reduced order. No, this is also wrong. So the answer is D part, which tells us that first term is integrated with full order and second term is integrated with reduced order. So about question number 7 and 8, I told you in the last class that the question, the diagram is missing, and I have already discussed this two question, the seventh and the eighth one, in the previous class, to tell you about how to solve it and what will be the correct figure related to it. So I hope you can all have done it, and I don't need to discuss it again. So 7 8th can be done if you still haven't seen that video, you can go to the YouTube link and see the previous lecture. Now let's go to question number 9. So one more thing I can discuss about this full integration and the reduced integration. So what happens? Let's say we have a degree of polynomial as 3. Okay. So when we solve it by full integration, full 3, it will be exact solution. But if we'll use a reduced integration, let's say we are using one Gauss point, and that will not be exact. So it depends on the accuracy of whatever we, how much accurate solution we want. In certain case, we reduce the full integration to a reduced integration. It's still we get a very less error in it. So why not do a trade-off between the computational cost and the error? Since by increasing the number of points, the number of Gauss points at the which the integration is performed, when we reduce it and the error is not reducing that much, why not reduce the computational cost? So that's why the reduced integration is being made. And the second advantage of this is, I'll tell you later. So what is this? So it depends on accuracy of what, of solution which we want. As FEM gives approx solution, but computational cost is also important. Now, the another advantage of it is, what happens sometimes if you are doing a cantilever beam, that this P is applied and you see the deflection is something like this, the original deflection. And when you do it with the FEM solution, you get this above. So what FEM solution is giving? FEM solution gives stiffer solution, then exact solution. Thus, to smooth the feature, in the smooth the the curve or the deformation curve, we perform reduced integration, so that the deflection is not deflection, it will be deflection here, not the deformation, or from the reduced integration. So this is all about, I have to talk about the full integration and the reduced integration. So question number 7 and 8 I have already discussed in the last class, you can refer it. Now let's go to the ninth question. So by the way, the answer for this is, seventh is B and eighth is C. Okay. Now what question number 9 is saying, consider the following functional of multivariate and find the corresponding Euler-Lagrange equation. So this is the functional form it is given. Let's start solving. So f is depending on the x as the dependent variable, and y dash, z and z dash as a dependent variable, independent variable. So let's start with, since it is having y also, z also, so we know for multivariate, for univariate, what we'll write, this is the Euler-Lagrangian equation to solve and get the differential equation for univariate. Now as our number of dependent terms are independent terms are increasing, we need to increase these equations for each of that variable, and we can write del f by del yn minus d by dx of del f by del y and dash equals to 0. So when we solve all these equations belonging to each of it, we'll get the different differential equations based on the different independent variables. So since here two terms are there, two variables are there, y and z. So two equations, what can be written as del f by del y minus d by dx of del f by del y dash equals to 0, and del f by del z minus d by dz of d by dx as the dependent variable, then del f by del z equals 0. So these are the two equations. Now the solution, if we see, the first one is not correct because it's coming as minus and here it is positive. In both minus is C, so C is the answer. Let's focus on the question number 10, which says identify the incorrect statement in corresponding to Timoshenko beam element. So it says two node linear element with reduced order integration cannot capture and the thin beam response even higher number of mesh as it considers linear variation of displacement, whereas as the actual deflection is cubic or higher order. Actually this is the answer. Let's see other options as well. In Timoshenko beam element, reduced integration element performs better than full integration element. So this can be a good thing, but it it is not always true. So this cannot be the option. So other option of number C is two node linear element with reduced order integration can capture the thin beam response. The number of mesh is required is high. So this is also not correct. It is not the high thing. In reduced order integration with quadratic element performs better than the reduced order linear element of our thinking. This is also not correct. So the option is A, which is correct. So this is the theoretical question which must have been covered in your theory class. So these are all the questions which were present in the quiz number 5. Let's take a 5 minutes break, and then I'll cover the questions which are belong to the question, assignment number 6 as well. Okay, let's start the session again. So, till now I have covered the solutions of the quiz 5, which has been already submitted by you. Now I'll discuss the questions which are related to week number 6, and they are all same, which will be asked in the similar pattern which will be asked in your quiz number 6. So, let's start. So, this question says, consider the following frame member AB and consider node A as initial node and B as final node. Okay, it's going opposite. Find the transformation matrix corresponding to the member AB, and these are the options which are given. So let's solve it. So we already know whenever we write a transformation matrix, we write it like this: cos theta, sin theta, minus sin theta, cos theta, and this is 0 0 0 0, and it's a 4 cross 4, so it will be cos theta, sin theta, minus sin theta, and cos theta. This is the generic transformation matrix we have seen for 4 cross 4 cross 4. Now in which this is 1, this is 2, this is 3, this is 4, and this is theta. Now what question is saying that this is A, this is B, this direction is 1, this direction is 2, this direction is 3, and this is 4. Now they have reversed it. Along with this is, oh sorry, this is third. They have this also. So 4 5 6. Okay, so 4 5 6. So one thing is that to remember, the rotation degree of freedom have no effect of transformation. Now what we have to find? We have to find the angle between this. So it is known that this is 30 degree. So this will be 30 and this will be 150 degree. Now we have to get from first axis the angle of the bar, which will be this. So directly we can write theta equals to 360 degree minus 150 degree, which is 210 degree. Now let's calculate the values of cos theta and sin theta for 210. So which will come into be like this: cos theta, which is equals to cos 210, and it will come up to cos of 180 plus 30, all is in degrees, which will give it to minus of cos 30 degree, which is minus root 3 by 2. Now similarly we'll calculate sin theta as well. Sin of 210 degree, which will be minus of sin 30 degree, and it will give us 1 by 2 minus. So transformation matrix generalize for 6 cross 6, what will we write? It will be cos theta, sin theta, 0 0 0 0, 4 zeros, because now we have a moment as well, means rotation, displacement, DOF as well. So this is minus sin theta, this is cos theta, and 0 0 0 0. And as we know, the degree of freedom of rotation do not changes as per the rotation, the transformation. So it will give you 1 here. Now similarly we'll repeat for this, so it will be cos theta, sin theta 0, and minus sin theta, cos theta 0, and 0 0 1, and here it will be symmetric. So this is the generalized transformation matrix when we have a moment as the rotation degree of freedom as well. So just we have to substitute the cos theta and sin theta in this, and what we'll get minus root 3 by 2 minus 1 by 2, then 4 zeros, then 1 by 2 minus root 3 by 2, 4 zeros, then double zero, 1, and triple zero. Then it will be repeated as the above, which is minus root 3 by 2 minus 1 by 2 and double zero. No, no. It will be 1 2 3 4 5 6. 1 2 3 4 5 6. Okay. Oh wait, it will become start from here. So minus root 3 by 2 minus 1 by 2 0, then 1 by 2 minus root 3 by 2 0, and double zero and 1. This side it will be symmetric. Okay, so this is only the question which was asked. So the option which will come to be, I think all are negative. The this 1 by 2 is positive. So let's see the option. Minus 1 by 3 root 3 by 2. This will be 4. Okay, here this is the answer because it's symmetric. So here will be minus 1 by 2. But what is the difference in C and D? This it will not be this. So answer is D. Okay, so let's go to question number 2. This question is very related to your question assignment question. If you solve this, it will be very helpful for you to submit the assignment. Let's start this question. Consider the following continuous Euler-Bernoulli beam and answer the following question. Each segment of beam is discretized into two elements and global degree of freedoms are shown with red. Loading of the beam is shown in figure and UDL is of 12 is given. Consider the constant EI. You need to use the code shared in the forum to solve these problems. Okay, we'll do that. So after assembling the stiffness matrix, force vector and equilibrium equation looks like this. We all know this. This is the general. The Ku is equal to F. Then UU is the unknown degree of freedom. UK is the degree of freedom. What will be the joint loading vector QK? Degree of freedoms are arranged in order of this. Okay, so let's start solving with hand first, then we'll go to the code part. So let's make the beam which is given in the question. Will be 1, that be 2, this is 3, this is 4, and 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if you see the one support is here and one support is here, and the loading, if you see one loading I can see at C of moment. C means A, B. C means the ninth and 10th. So one loading will come here as 20 kilonewton meter, and one at the end which is 10 kilonewton. Okay, so these are two loading. Now let's start solving the question. So we can see directly that you known. What are the you known here? We know this, we know this, and we know this in the vertical direction. So directly what we can write, known ones are 1, 2, 5, and 9. Corresponding you unknown are the rest one which are left out, which is 3, 4, 6, 7, 8, 10, 11, 12, 13, 14. Now in the first question it has been asked that find the q of known. So q of known is to be calculated. Now directly with hand we can write q for element 1. Q will be q1, 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 q1. Then will be 1, 2, 3, 4 based on the nodes, based on the nodes. Okay, based on degree of freedom. Then it will be q1 dash, q2 dash, which are the reaction forces, and rest 2 are 0. We can see here there is no external force applied. Similarly for element number 2 we can write q as q2, 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 and for this it will be 2, 3, 3, 4. It will be 3, 4, and 5, 6. It will be 3, 4, 5, 6 based on the degree of freedom. So if you say the top two will be 0, and for reaction, if the reaction is to be calculated, and q2 will be there. Similarly for element number 3, q will be, we'll write q3 first, then degree of freedoms, which will be 5, 6, 7, 8. I'll tell you how this is. So we see the element number 3, which is this. So it depends on 5, 6, 7, 8. So if you see here, q3 5 will be there, q3 6 is 0, q3 7 and 8 are also 0. Similarly for element number 4, it will be q4, 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 q4. It will be 7, 8, 9, 10, and whatever it will come. So similarly for all the elements we'll write and combine to get q. So what q we'll get, it will look something like this. Let's combine this q as it will be q1, 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 q1 plus q2, q2. This was for 1, 2, 3, 4, and 3, 4, q2, q2, 5, 6 plus q3, 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 3, 4, 5, 6, then 5, 6, 7, 8. Then from 7, we'll start with Q4, 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 Q4. So this will be 7, 8, 9, 10. And it will be Q5, 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 which will be 10, 11, oh, no, will 9, 10, 11, 12. Similarly, one more will come, which is Q6, Q6, and Q6 and Q6, which will be 11, 12, 13, 14. That's it. So with this will give you some Q1, this will give you some Q2. These both we have proved it as 0. We have shown this is also 0. This is as Q5, then Q6 is 0, then Q7 is 0, Q8 is 0. This will come to Q9 because 1 to 9 is the 1, 2 and 9 has the reaction forces. For Q5, this Q the 10th node we know the it is like minus 20, others are 0, but for the last Q6 14 it is 13, it is minus 10. Why 13? Because it's in the vertical direction. So if we write Q of known, it will become 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, then minus 20, then 0, then 0, then minus 10 and 0. Transpose of this. So this is the known Q vector which needs to be calculated in the question, and if you see the solution is as B. Now the next question which is linked to this is what will be the rotation of joint B? Joint B rotation we have to calculate here. A, B, C, D, I'll let you know what it is. Okay. So we have to find the rotation of this hinge point. Now since the beam is having too much of nodes, so you can't solve it directly with hands. You have to solve it with the MATLAB code which is already given to you. I'll show you the content of it, what it is showing, so that you can use it accordingly in your assignment problems. So I'll share my screen of the MATLAB. Okay, I hope this is visible to all and you all are able to see my MATLAB code. So what I can do, I can share in this as well if possible. Okay, so what I have done, I'm now sharing both screens so that you can make one of it the MATLAB code screen as big, and no, that is I think stop sharing. I'll do. I hope you have the solution for that. The question you have already noted the a question and we can directly think of it. Or we can do one more thing. I think now both things are visible to you. This is the question which we are solving, and I have modified the code which is provided to you. So I'll briefly discuss how this code is working so that you can change accordingly in your question and get the solution. So the I'm solving in MATLAB. So I've copied the content of the code and pasted in the MATLAB, and this is the assignment number 6 beam question which I have shown in the right tab. Okay, so these two CLC and clear are used as the initial command for clearing the screen. The L is the now the first is the nodal coordinates. So what are the coordinates here? We have to define that. So L is the length of beam, which is 2, 2, 2, and 6. So this is 6. Now N is the number of elements. So we are making 1, 2, 3, 4, 5, 6. 6 elements are there. So number of element is taken as 6. Now H is the distance of the or length of the each of the member. So when you do L by N, you will get a 1, which is 1 meter of each of the element. So you get H as the length of the each element. Now to get the nodes, what you will do, I'll this first. So I'll run. Okay, now if you see by this what we get the points at which we are getting the nodes. So 0, 1, 2, 3, 4, 5, 6. So at each 0, 1, 2, these are the nodes, nodal points. Now as we have defined the nodal points, we have to define the element connectivity, like which element, which node is connected to which. So what we are doing, we are writing this. Let's see what it gives. So see, it will give you 1, 2, 3, 4, 5, 6. Now we are making a element vector or the matrix in which the first row columns are first column will give you this, the value of first node, which will be for a 1, 2, 3, 4, and the second column will give you the nodes which is connected to it. Means since it is 1, it will be connected to 2, so it will come 2 in the next node. Let's see what it gives. So let's see, 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, 4 is connected to 5, 5 is connected to 6, and 6 is connected to 6, 7. So we have connected and told the computer which node is connected to which node, and we get the element vector. I'll show you here. See, 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, 4 to 5, 5 to 6, and 6 to 7. Now we have to we are calculating the total number of nodes. We are calculating the length of this node vector, which will stored in the number of node. By calculating the size of elements, we are getting the number of elements, And since each of the node have a 2 degree of freedom, so we are calculating number of degree of freedoms by multiplying it by 2. So to define the element properties, we have run a loop for 1 to number of element, and providing each e and I as 1. Since it is constant, we can take any value since it is not given. So let's start with doing with 1. The next is the boundary condition you have to specify. So boundary condition, let's observe what it is. Boundary condition need to be decided at each of the node number. So the first is the node number, which is 1 2 3 4 5 6 7, and for that, if you see the code, it is saying the second term is transverse boundary condition and second is the theta. So if you go to first node, and for 1 it means no constant, and 0 it means the degree of freedom is constant. So when you see the first node, the w is constant, so it is 0. Moment is constant due to fixed loading, so it is 0. If we see the second node, which is this, so in this case, both are not constant, so it will come 1 1. For third node, only the w is constant, so it goes to 0. Non-constant value, which is theta, is 1. For the fourth, third is the fourth, which is 1 2 3 4, nothing is constant, so both are 1. For fifth one, again w is constant, so it is 0. In sixth and seven, we see both are free ends, no support is there, so they are also not constant, so we gave it as 1. Now we have to define the external forces. Now, which of our node is having the external forces? Do a node means first node is having the any loading? No. Only we have seen that one moment is acting at 10 and one loading is acting at 13. So which with this 10 belongs to 1 2 3 4 fifth node. So fifth node is having minus 20. So we can define this, write it in this way. The first term is node number, second is whatever shear is acting, whatever moment is acting will come next. So for fifth node, only the moment is acting, shear is not there, so shear is termed as 0, and for moment the opposite direction it is there, so it is minus 20. Similarly, for seventh node, which is the last node, we can say that minus 10 is acting in the shear and no moment is acting. So this is based on the point load. Since we have a distributed load as well, which is 12 in the downward direction, so it will be minus 12. So when we defined it, it will be done. Now what we are doing, we are initializing the stiffness matrix, displacement matrix vector, and the force vector. So initially we'll take u, kg and f as 0, so that MATLAB don't have to change the size of these variables again and again. By doing again and again, the MATLAB reduces its speed. So it's better to predefine it as 0, so that we can directly get what size it will happen. So because we know according to degree of freedom or the number of nodes, what will be our size. So we know the size of displacement vector will be 2 into number of node into 1, and for k matrix k global will be 2 into number of node into 2 into number of node. Similarly, f will be 2 into 1. So let's the next column, the next section discusses the how to put the applied loads at degree of freedom. So we have defined the degree of external forces and how it is distributed. We have to see here. Now till now we have distributed on the basis of nodes. Now we have to distribute on the basis of degree of freedom, because we have to write ku is equal to f, which is in the form of all the degree of freedom. So when you run the loop for 1 to size q1, let's see what is the size of q1. It will be 2. See, so it is 2. So what this loop is doing, it is running from 1 to 2, because this is having, each q is having 2 forces, so it will run for 1 and 2. Now it is initializing JSQI. The first QI will be Q1. So Q1, what will give? It will give 5. So J is having at what node we are having the forces. So initially when I is 1, it will give you 5 as J. Now since Q is based on the nodes value, now we have to distribute this on the basis of degree of freedom. So 1 degree of freedom will have this, 1 degree of freedom will have this. So that's why if you see, since we get J as 5, means fifth node is having, according to fifth node if we see 1 2 3 4 5, fifth node is having degree of freedom as 9 and 10. So F will store the value of -20 in the 10th node. So and 0 in the ninth node. So ninth, if it is, we have got 5, so 5 into 2 10, minus 1 9, and 5 into 2 as 10. So F will store from 9 is to 10 as Q of 2 is to 3. So Q of 2 is to 3 is 0 and -20. So F9 will be 0, F10 will be -20. F9 will be 0 and okay. Now similarly when it runs for the second size, it will go with 7, and since 7 it will be 13 and 14, which we'll get from this formula, and it will fill F13 as -10 and F14 as 0. Rest all nodes will be 0 force, and it will be, or it is already done when we have done this F as 0. Now next thing we have to get how to put the boundary condition in it. Now we know that KUU and we have distributed on the basis of known degree of freedom and unknown degree of freedom. So let's see what are the known degree of freedom. The similar things which we have done here till now, we have given the boundary conditions in this on the basis of nodes. Now we have to convert these nodes into degree of freedoms, boundary conditions. So for degree of freedom, this will be 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So as we have done for force vector, which is 2 into j minus 1 and 2 till 2j, similar things we are doing here, and putting a initial variable as I1 and I2. So for, we are running it for size boundary condition. Since we have given for 7 nodes, you see this will be 7 here. So this is 7. So this loop will run 7 times, which is the 7 nodes we have given here. Then for the first one, what it will do, it will see the first one is, and it will store the values of 0 0 in the first loop for I1 and I2, and it will check if this is 0, then it will go up to if in this loop, otherwise it will go into this. If any one of this is 0, it will go in this loop and put a put a known u as that value. Otherwise, if it is not the 0, that will be termed as unknown degree of freedom. For unknown degree of freedom and for all known degree of freedoms, it will give you the id uk will be updated, and you will get the vector with known uk. For forming the the unknown degree of freedom, this loop will run till the number of degree of freedom, which will be 14 here, and for each id which is not mentioned in the above one, will increase the flag value, and that flag value will put the unknown degree of freedom in that. So you will have a different vector for a known displacement and different vector for unknown deflection. Now what we are doing, we are putting the zeros for k, ku and k uu, which is known and unknown value of k, and we are putting the values of k matrix for each of the element we are calculating with the formula, which is already discussed in the class, and we are solving it using the line solve. Means what line solve do, you don't have to put the inverse of k matrix and then do the solution, because inverse function takes too much of time in MATLAB. So you have a predefined function in MATLAB, which is line solve, It directly solves your inverse and don't take much of the time. So when you solve it, you will get the UU and FU, and with along with that, you can distribute on the basis of U as W and theta, and you will get the final solution of it. So this was the code. I hope you all have understood. It's not that tough. It's not that easy as well. So I hope you have understood, and that will be helpful for you all in this. It will be helpful for the assignment of this week. So all these assignments this time it consists of a of the MATLAB program as well. So you all have to go through it. First, you try to solve the problem with the hand so that you get the gist how much degree of freedoms are there, how many nodes are there, and the basic values of Q, and how many unknown deformation displacement is there, how many known deformation displacement is there. Accordingly, you can change the your basic code which is given to you, the number of nodes, number of displacement, and all you can do it. And one more thing along with this, I have discussed the beam thing. The in your assignment there is a truss and frame question as well. Similar way that codes are also present. I hope that by you listening to this lecture you will be able to easily solve that as well. Today's 20, this is today's third. I think that the last day of submission is 5th or 6th. So if you have any doubt till now, you can see this lecture for better understanding. Beside this, I have discussed today of whatever all I had today, and so this question can be done. The next question was the theta and the joint reactions with the B and C. So all this can be easily done when you solve the problem in the MATLAB code, and you will get a perfect solution with this. Since we have assumed E and I as one, so you won't see the E and I in the solution directly. If the answer is, say, if it is something means, let's say it is B, so you will get a minus 1.37 value in that for that degree of freedom. So that's all I have for today. We have done today assignment 5 solutions, along with we have discussed the question week 6 solutions along with the MATLAB coding. So that's all for today, and thank you. I'll wait for 5 more minutes. If you have any doubts, you can come. Otherwise, you can post it in the Google forum as well. I'll try to give the reply. If not, I'll ask them you to. I'll take the doubt in the next class, and that's all for this class. Thank you.